All right, for today, I think you're going to find that the problems will be pretty easy today. We are going to be doing more with variables. We're eventually working to get to the place where we can solve equations. That is what I'm striving for, because whether you take pre-calculus or whether you take statistics, you're going to have to solve equations in either one. And so that's what I'm ultimately trying to get to, is solving equations. And in that manner, hopefully, you'll be ready to move on to a different course. Okay? All right, so let's start. And now a lot of this today is going to be also getting back to the order of operations. Please excuse my dear Aunt Sally. But before we get to that, let's just first talk about collecting terms. Okay, simply collecting terms. I want to collect terms here. I see some x's, I see some y's, I see a number all by itself. So you can collect terms going by the rules we talked about the last time. When the signs are different, you subtract and give it the sign of the biggest. So 3x and a negative 1x, the signs are different. You subtract 3 and 1, give it the sign of the biggest. 2x. The y's, I see a 4y and an 8y, that makes 12y. And we simply have a negative 7 to put on the end. Okay, that's all there is to it. This one over here is a demonstration of the distributive property. Okay, I don't know what x and y are, so I can't figure out what's on the inside of the parentheses. Like the order of operations says, do parentheses first, but I don't know what x and y are. So I'm going to take 6 into both parts. I'm going to take negative 3 into both parts by the distributive property. This becomes 6x minus 12y. Remember, one negative keeps it negative. Multiply negative 3y. Multiply negative times a negative is a positive 6x. Are you with me? Okay? Then this is going to give me a final answer. Let's collect terms. A positive 12x and two negatives make a bigger debt, a negative 15y. Everybody able to see that? You're with me? Okay. Now, down here, you must do the parentheses first, but I don't know what x is again. So I'm going to take the negative into both, and I'll have 10x minus, it becomes a negative, and minus a 5 when I take the negative in. Collect terms. 10x minus 3x is 7x, and it's simply 7x minus 5. Here, you can divide this out, but you have to remember to take the 3 into both parts. 3 into 6x is 2x. 3 into 15 is 5. Now, down here, this will get us back into the order of operation. I'm going to put 1 in for the x and 2 in for the y. So 3 times 1 is 3. 2 times 2 is 4, minus 5. A 7 minus 5 should be just 2. Over here, x is 1. 1 squared. 1 times 1 is 1. Y is 2. 2 squared is 4. That answer is 5. Okay? All right. Let's go on down. Okay. Same thing here with distributive property. You can take the 6 into both parts and get 6x plus 12y. You're finished. Here, you don't have anything to take into the first set, so you can get rid of those parentheses and just write it x plus y. But here, you have a negative sign you have to take into both, is a negative x minus y. The x's go away, the y's go away. You have 0 left. So the answer is just 0. Okay? All right, now getting a little tougher down here. When x is 3, you put 3 here. 3 cubed is 3 times 3 times 3. Make 3 times 3 is 9, times 3 is 27. Y cubed is negative 3 times negative 3 times negative 3. So it's still 27. but there's 3 negatives, which makes it a negative 27, and I get 0 again. All right, 5 times x would be 15. 5 times 3 is 15. 2 times a negative 3. 1 negative is going to still 6, but it should be a negative 6, makes 9. Go down here, you must do the parentheses first. 3 plus negative 3, they add out. They go away to 0. Anything times 0 is 0. You can take the 4 in here if you want, but because I know what x and y are, I can put the x and the y in also. So if you put the x and the y in, x is 3, y is negative 3. So I have 4 times x is 3, y is negative 3, and negative 2 times a negative 3 is a positive 6. That's 9 times 4 is 36. Okay, if you would have taken the 4 in first, you would have had, you'd have 4x minus 8y. Are you with me? And then x is 3, so 4 times 3 is 12. 8, a negative 8 times a negative 3, 2 negatives makes a positive 24, and you still get 36. Okay? Now, getting into just a wee bit of algebra here. Okay? Remember what I said. I'm trying to get you ready to solve equations. Okay? You must look at this. These are English words that we speak. You must look at these as being a different language. We want to get it into algebra. This is a different language than algebra. So we need to translate it to algebra. Okay? And that's what all of mathematics is about. You want to be able to translate something to mathematics so you can solve the problem. I'll probably end up telling you this story a couple of times, but if you go in a grocery store, okay? If you go in a grocery store and you're trying to figure out which can has been produced that makes the most efficient use of the metal materials to make the can. Like for instance, supposing you graduate from SU and you get a job and your boss tells you, I want you to design a tin can that'll hold the most amount of food and use the least amount of metal. That's a fantastic problem in the world in which we live, in which we're trying to conserve our natural resources. You want to try to save our very precious minerals, and you just don't want to waste them. So there should be a way, like you can have Pringles cans, real tall, skinny cans, right? That use a heck of a lot of materials, or real short, squatty, wide cans like tuna fish cans or cat food cans. They're real flat. Either the Pringles cans or the real flat ones, they waste a lot of metal. The best way to build a can that'll hold the most amount of food and use the least amount of metal is if you hold a can up and look at it. Next time you go in a grocery store, do this. Hold a can up and look at it from the side. If it looks like a square, it will be the most efficient made can for that amount of volume. Okay? And how was that figured out? By translating that situation to mathematics. It's actually a calculus problem. Translating it to mathematics, then you can solve the problem. Fascinating, fascinating problem. Okay? Do that next time you're in a grocery store. So think about soda cans. Soda cans, are they efficiently made? No, they are not. And why aren't they? Because they want little kids to be able to hold on to them, right? They want little kids to drink the soda, put the money in the machine. And if you made a soda can with the most efficient use of the aluminum, it would look like a square, kind of like, have you guys ever seen, I call them the little chubby cans, you know, they're a little shorter. If you hold up a soda can, it doesn't look like a square. A 12-ounce soda can is too tall. But if they made it to use the aluminum wisely, little kids wouldn't be able to hold on to it and they'd lose sales. Shouldn't have got started, sorry. There we go. Let's translate this into algebra. The sum of a number and 3. Sum means add. X plus 3. The difference between 2 and a number. Difference between two numbers is subtraction. 2 minus x. The product of a number and its opposite. The product of a number and its opposite. Is that not x times x, which is x squared, and there's one negative sign? Yeah. 8 more than the sum of 6 and negative 5. I didn't want an answer. Well, it does say simplify. Pardon me. Yes, we do want an answer. So you must do the sum of 6 and negative 5 first. Okay. Sum of 6 and negative 5 first. I'm going to have to do that first. 6 plus negative 5. Then I want to add 8. Okay. I want to see you write this down, just so I know you're thinking about what's going on here. 6 plus negative 5, you subtract and give it the sign the biggest 1. 8 plus 1 is 9. The product of 8 and 3 divided by 4. Product means multiply. 8 times 3 divided by 4. Then you can get the answer, which is 24 divided by 4, which is 6. The sum of 11 and 9, and I think that's decreased by negative 5. 11 and 9, you want the sum of that. 11 plus negative 9 decreased by negative 5. Kill those guys. Kill those two negatives. So you have a positive 2 here. 2 plus 5 is 7. The quotient of 3, quotient is the answer to a division problem. So the quotient of 3 and the sum of 1 and negative 2. Are you with me? Right? Because you have to do the sum, the addition part, before you can divide. So 1 plus negative 2, subtract and give it the sign the biggest, negative 1. 1 into 3 is still 3, but there's one negative sign, so it's negative 3. 8 less than negative 7, and then divided by 5. Okay? 8 less than negative 7. If you take 8 less than, you must take 8 off of negative 7. So I want negative 7. I'm going to take 8 off of it. Then I am dividing by 5. Okay, so 8 less than negative 7 divided by 5. This is negative 15 divided by 5, which is negative 3. Now, I don't think this problem is worded too well. I'm going to have to fix it up, because I don't know whether I want to do the 8 less than first or the negative 7 divided by 5 first. Somebody in here might say, wait a second. I think it should be negative 7 divided by 5 and then 8 less. Okay? And I would have a hard time arguing with you. I think you're right. You can interpret this problem in two different ways. All right? It was not explained as best as it could have been. Okay, so that was a real short, quick, easy one today. You've got 2 pages, once again, for homework, but you should not find these to be difficult.